All right, guys, Mr. Antonucci here, and in this video, I want to share with you some basic introductions to parametric equations. So let's start off with the definition of a parametric curve or parametric equations. So this is the case where x and y are determined as functions instead of just simple variables. So x is determined by a function f of t, and y is determined by a function g of t over an interval of t values. Typically, this is going to be t representing time, and x and y model the path of some kind of moving object. So any coordinate x and y depends on the value of t that's given by f of t for x and g of t for y. So this is called a parametric curve, and the equations that correspond to this curve are called parametric equations for the curve. So let's get into one. Let's describe this relation determined by x equals 3t, that should be 3t, not 3x, and y equals 9t squared for t greater than or equal to 0. Typically, whenever you see parametric equations, you're going to have an interval for t values. So I'm going to first show you this on the TI-83. So if you go to the y equals menu, notice it's all in terms of y. What you want to do is click mode and then go to the fourth line, scroll over to par. It stands for parametric equations. There are other options. We're not going to get into those right now. And then go to your y equal menu. The first one you're going to enter is x is 3t. Let me clear that out, 3t. And notice when you hit the x variable, it automatically puts in a t now because we're in parametric mode. Let me clear this off, and you would get 9 t squared. Okay, then to set the t interval, you want the t min to start at 0 because this interval starts at 0. And then the max, since t is greater than or equal to 0, that means it goes off to infinity. You can't really put in infinity, so we're just going to put in 1000 for the upper limit. Okay. Now if I hit zoom 6, that gives me my standard viewing window. And notice it traces the curve. Notice it's kind of like the right-hand side of a parabola. The initial point is the point where it started. If I hit graph, let me hit zoom 6 again. Notice it started at the origin and moved up and to the right. With parametric equations, the parameterization, how you parameterize it, determines the direction that the graph will go in this case. Now I'm going to show you this in Desmos, but I do want to show you something real quick. You can solve for the Cartesian equation in some circumstances. So if I take my equation x equals 3t, then that means that t equals x over 3. If I substitute that in for t, I would get y equals 9 times x over 3 squared. And if I square that, you have 9 times x squared over 3, which would be x squared. So the corresponding Cartesian equation would be y equals x squared. Now, if I went and I graphed y equals x squared, you would have a complete parabola like this. To get it to line up with the exact parameterization we have here, you would have to restrict the domain to be x greater than or equal to 0. Okay? All right, so let me show you how to do this over in Desmos. Let me bring Desmos over. Okay, so we have Desmos over here. So in order to graph parametric equations in Desmos, it's really simple. All you do is start an ordered pair with a parenthesis. And then for the x, you just put the x parameterization, which in our case, it was 3t, comma, then you could put a space if you want, 9t squared for the y one. Now notice it only graphed the equation up to here, up to this point, because down here it gives you the t interval. Now this said for t greater than or equal to 0, this is just going, for our problem, this is just going from 0 to 1. So if we increase that to 2, then notice you would get more of the graph, but not all of it. Again, if you went out to 1000, I mean, it would eventually stop. it's going to be way up there. So I'm not going to keep zooming in, but that's basically how you do it. You put it in as an ordered pair, and you put the X equation in for the X spot and the Y equation in for the Y spot in terms of T. And then you can put the interval, whatever you want it to be there for that one. Okay. All right, guys, that's it for just an introduction to parametric equations. Hope that was helpful to you.